Okay, this next example, we're dealing with partial decomposition of a rational function when the denominator has repeated linear factors. So the partial fraction decomposition of a rational function when the denominator has repeated linear factors occurring n times and the degree of p of x is less than the degree of the denominator. So we're writing the denominator powers in increasing order. So you can see here's the denominator, and then we increase it again because it's squared, and then again when it's cubed. And it all depends on what is the power of n. So, given a rational expression with repeated linear factors, we're going to decompose it. We're going to use a variable like a, b, or c for the numerators and account for increasing powers of the denominators. Number 2, we're going to multiply both sides of the equation by the common denominator to eliminate fractions. Number 3, we're going to expand the right side of the equation and collect like terms. Number 4, we're going to set coefficients of like terms from the left side of the equation equal to those on the right side to create a system of equations to solve for the numerators. Example 2, we're decomposing with repeated linear factors. So we're going to decompose the given rational expression with repeated linear factors. So the first thing we want to do is, if we look at this denominator, okay, we need to factor it so that we can then see the repeated linear factors. Now the numerator we can keep the same. So the next step, what I do is I can factor out an x. When I factor out an x, what I'm left with is x squared minus 4x plus 4. And when we factor that, we get x times x minus 2 squared, which is a repeated linear factor. Now, in step 1, the denominator factors are x times x minus 2 squared. So to allow for the repeated factor of x minus 2, the decomposition will include 3 denominators: x, x minus 2, and x minus 2 squared. So therefore, on the left side, we have our denominator in factored form of what the original expression is. And so the first denominator is going to be a over x plus a second denominator, which is b over x minus 2 plus c over x minus 2 squared. And so next what we're going to do is we're going to multiply both sides by the common denominator, and the LCD is x times x minus 2 squared. So if we multiply the left side by x times x minus 2 squared, we eliminate the denominator and we're left with negative x squared plus 2x plus 4. On the right side, we need to see what we can eliminate. So when we multiply both sides by x, or the right side by x times x minus 2 squared, we eliminate the x, but we have a times x minus 2 squared. If we look at the next term, the middle term here, if we multiply it by the LCD, we're going to eliminate one of the x minus 2 squareds. So what's left is b times x minus 2. And then over here on the last one, if we eliminate the x minus 2 squared with the denominator c, then we're going to get cx. And now step 3, on the right side of the equation, we're going to expand and then collect like terms. So by expanding, if we look at the previous step, we have x minus 2 squared. We're going to multiply that all out and get a times x squared minus 4x plus 4. So let me show you that here. And we're going to multiply it out to get x squared minus 4x plus 4. And then we're going to keep plus bx times x minus 2 plus cx. And now what we're going to do, we're going to keep the left side of the equation the way it is. We're going to distribute the a to those 3 terms. So we're going to get ax squared minus 4ax plus 4a. Then we're going to distribute the bx. So we're going to get bx squared minus 2bx and then plus c. And now when we collect like terms, we're going to collect all the x squareds, all the x's, and all the constants. So if we look at the x squareds in here, there's an ax squared and there's a bx squared, and that gives us that, a plus b times x squared. If we take all the x terms, we have negative 4ax, we have minus 2bx, and we have plus cx, and you can see what happens in this middle term. So we get negative 4a minus 2b plus c times x. And then the last one represents 4a. So there's our 4a. And so now what we're going to do is then we're going to compare the coefficients of both sides, and this will give the system of equations in 3 variables. So let's take a look at the first term on the right side. We have a plus b, which is the coefficient of x squared, and the coefficient of x squared on the left side is -1. So we can write that now as an equation. Equation number 1 is a plus b equals -1. And again, we're only looking at the coefficients. Now, if we take a look at the coefficient of the x term on the right side, we have -4a minus 2b plus c, and it's going to equal the coefficient of the x term on the left side of the equation, which is 2. So we have -4a minus 2b plus c, which is equal to 2. And then the last one, we have 4a, which is going to equal the constant because it doesn't have a variable there, so 4a is going to equal 4, so our third equation is going to be 4a, which is equal to 4. And so now in step 5, we're going to solve for a since we have one variable in equation 3. So if we divide both sides by 4, a is going to equal 1. Now in step 6, we can substitute a equals 1 into equation number 1. Equation number 1 is a plus b equals -1. We're going to plug in 1 for a, and subtracting 1 to both sides, now we get b, which is equal to -2. And now that we have a and b, we can then solve for c by substituting the values for a and b into equation 2. So equation 2 is -4a minus 2b plus c equals 2. We're going to plug in a to be 1 and b to be -2 and then solve for c. So we end up with -4 plus 4, which is 0 on this side. So we know that c is going to equal 2. Now if we go back up to the original problem and how we set this up, we have a over x, b over x minus 2, and c over x minus 2 squared. So now we can fill those numbers in. So now we know that it's going to equal 1 over x minus 2 over x minus 2 plus 2 over x minus 2 squared.